Alright, so term 1 final, we have a couple of tops. These two I recorded them already, فخلصنا منهم. Well, this one I recorded it already, خلصت منه. But it's just 4 questions we're gonna do. We're gonna do them now really fast. So over here, we're gonna start. Question 1. What is the domain of f of x? Now, you have a radical. For a radical, you need to make sure that that radical is never negative. So we took this a long time ago. How do you make sure? Simply you set what's under the radical greater than or equal to 0, right? Because we know that it can't be negative under the radical. So we say 1 minus cosine x greater than or equal to 0. 1 to the other side. Negative cosine x greater than or equal to negative 1. Divide by minus on both sides. You get cosine x less than or equal to 1. And I think all of you know that cosine x, no value for cosine x will ever get you something bigger than 1. So it will always be less than or equal to 1. Okay, so this is always true. So therefore, the domain x belongs to the set of all real numbers. Okay, we put like x belongs to R. So is that how I did it here? Yeah, so the domain is set of real numbers. You can just say the domain is all real numbers. That's completely fine. Okay, what is the domain of f prime of x? We need to find what is f prime of x. Let's continue. What's f prime of x? Part B, let's derive. It's going to become 1 over 2 radical 1 minus cosine x times sine x. So it's sine x over 2 radical 1 minus cosine x. How did I do this? I simply changed 1 minus cosine x to the power of half, and then multiplied by the half, subtracted 1 by the power, so I took it down because it became a negative power, and multiplied by the derivative of what's inside. The derivative of 1 is 0, the derivative of negative cosine is sine, because derivative of cosine is negative sine, so negative cosine will get you positive sine. So this is the derivative. Now how do we check the domain? If for a fraction, how do you check the domain for a fraction? You know the denominator has to be greater than 0, cannot be equal to 0, right? And since it's a radical in the denominator, we did this in grade 9. If a radical in the denominator, what's under the radical has to be greater than 0, strictly greater. Okay? Here, it was greater than or equal, because it wasn't in the denominator. But here, since it's in the denominator, it has to be strictly greater. Okay? 1 to the other side, you're going to get negative cosine x greater than negative 1. So cosine x will be less than 1, because you're dividing by negative, so you flip the sign. Cosine x less than 1. Cosine x will always be less than 1, except for... Can you do shift cosine 1? Doing shift cosine 1, you're going to get x equals 0. What else? How do you get another solution for cosine? It's 2 pi minus the solution you got. So this, if the first solution is 0, that means sectional solution will be 2 pi. And then it keeps on alternating every 2 pi, right? So 4 pi, 6 pi, and so on and so forth. So how do you write this solution? You say you say that the domain, part B, it's always true, except at these numbers here, you're gonna get that if you do cosine 0, مثلا, you get 1. If you do cosine 2 pi, you get 1. How do you do this in the exam? When you reach this stage here, you do shift cosine 1, you're gonna get 0, and then you do 2 pi minus 0 to get the other solution. Anyways, but are these the only 2 solutions? No, there's infinite solutions. You can keep on going. So that's why we say it's all real numbers except for x equals 2, it's alternating 2 pi, right? 2 pi, and since each time you're alternating, we multiply it by a factor of k. Okay, that's how we do it. So you're alternating 2 pi, and since you're multiplying, you need the factor of multiplication, so we say k. So all real numbers except 2 pi k or 2k pi, whatever you want to say. That's how I said it. Yeah, 2k pi. And you can say where k is an integer. Okay, cool. Part C, write the equation of the normal. Alright, at pi over 2. How do we find the equation of the normal? Step 1, always find your y. Yeah. Step 2, because you need a complete point if you want to find a line. Step 2 is derive and find the slope. How do you derive and find the slope? You derive and plug this in. Now since we want normal, we need to do step 3, which is the slope of the normal is negative 1 over slope of the tangent. Because what you get here is slope of tangent. We want slope of normal. so you do negative 1 over that. Then step 4 obviously is y equal mx plus b. In the solution they used y minus y node equals mx minus x node, which you can use as well. This works as well, but I prefer this. Same thing, by the way. Anyways, so find y. X equals pi over 2. How much will it be? Radical 1 minus cosine pi over 2, which is 1. So that means it's going to be pi over 2 comma 1. So that's your point. Second step is derive. We did it over here, and find the slope. So substitute pi over 2 over here. Sine pi over 2 over 2 radical 1 minus cosine pi over 2. You get 1 on top, and then here you get 2. So it's half. So the slope is half. Since we want the normal, you have to do negative 1 over this. So flip it and make it negative. So slope with the normal is going to be negative 2. Last step, mx plus b. So negative 2 x plus b. What's my y and x? My y is 1. My x is pi over 2 plus b. And you get b is equal to pi plus 1. Why? Because this cancels with this. Negative pi, take it to the other side, becomes positive pi. So b is pi plus 1. So how does your line look like? It's going to be y is equal to negative 2x plus pi plus 1. Now if you look at the solution, it is in a weird way. They use this, which is the same thing. If you distribute, you're going to get the same thing, okay? Is Rolle's theorem applicable? For Rolle's theorem to be applicable, the first thing, it must be continuous on the interval. Now we know our function is continuous because it's a normal function. Over this interval we know it's continuous because we said that the domain is all real numbers, right? So that's cool. It has a full domain, no asymptotes, no discontinuity, nothing. So in part A we got all real numbers domain. 2, it must be differentiable. It must be differentiable on the interval. Is it differentiable? We derived it and found f prime of x, right? We found that the domain of the derivative is all real numbers except those 2k pi bullshit stuff, right? Now it's not like that. It's all real numbers except 2k pi. Yeah. Now how do we think about that? Over here, do you see any 2k pi? Is there any 2 pi between pi over 2 and 3 pi over 2? Pi over 2 you can think of it as 0.5 pi. 3 pi over 2 is 1.5 pi. Do you see a 0 or 2 pi in between this interval? No. So that's why f prime of x is going to be defined for all the points in this interval. So that's why we say it's differentiable over that interval. It's continuous over that interval. With the third condition is that f of a equals f of b. What's this? A and b are the endpoints of the interval. So plug in pi over 2 over here. You get f of pi over 2. Let's see, how much is it? It's 1. F of 3 pi over 2, come in, it's 1. So since these two are equal, and that means these three conditions are true, and therefore you can say Rolle's theorem is applicable over pi over 2, comma 3 pi over 2, closed interval. Next question, over here. Alright, so over here, equation of the curve, cosine 2x sine x, yeah? Very easy. Find dy by dx. Everyone knows how to find the derivative. You have to do product rule over here. So let's take u to be cosine 2x. So therefore u prime is negative sine 2x times the derivative of what's inside, which is 2, right? So let's just write it as negative 2 sine 2x. Okay, and then v is sine x. So v prime is cosine x. So u prime v, so it's going to be, we'll put part A, u prime v, so negative 2 sine 2x times sine x. Alright, plus v prime u, so cosine x times cosine 2x. Okay, and that's part A. Alright, so over here for part B, we want the stationary point, and we have to equate the derivative to 0, right? So very easy. You just need to know some trigonometry for this one. So it's gonna be minus 2 sine 2x sine x plus cosine x cosine 2x equals 0. Now the first thing we're gonna do is we're gonna use some rules that we know. Sine 2x is actually, if you remember from last year, it's 2 sine x cosine x. Okay, so we're gonna change this sine 2x into 2 sine x cosine x. So minus 2 times 2 sine x cosine x sine x outside plus cosine x cosine 2x. Now why did I do this? Because now I can factor out this cosine x. Okay, so it's gonna become minus 4. Let's factor out the cosine x. You have cosine x here and cosine x here, so we're gonna take it out. It's gonna become minus 4 sine squared x plus cosine 2x equals 0. Now, why is it sine squared? Because you have sine and sine, no? Anyway, that means here that, you know, when we're solving, we take, if it's equaling 0, and the one outside should be equal to 0. So let's test that out. Cosine x equals 0. If you do shift cosine 0, you get pi. Sorry, you get pi over 2. You get pi over 2, yeah. And is pi over 2 included in this interval? No. It has to be strictly less than pi over 2. So there's no solution for cosine x equals 0. So what do you do then? You have to solve the one inside, right? Minus 4 sine squared x plus cosine 2x equals 0. How can we solve this? You need to know that cosine 2x is actually this rule. Cosine 2x is 2 minus sine squared x, and that's what it was here. That's what they did. 1 minus 2 sine squared x. It's double angle, half angle قصدي. You do take 1 minus 2 sine squared x. Okay, فبasically هون هيدي cosine 2x becomes this. So it becomes negative 4 sine squared x plus 1 minus 2 sine squared x equals 0. So easy, you just need to know this formula. Okay, and then minus 4 minus 2 will become 1 minus 6 sine squared x equals 0. Other side, 6 sine squared x equals 1. Divide by 6, you're gonna get sine squared x equals 1 over 6. So it's gonna be radical both sides, so it's gonna be sine x is equal to plus minus radical 1 over 6. And we're gonna get two solutions. Radical 1 over 6, negative radical 1 over 6. What do? We do shift sign for both. Now it has to be in this interval here, so this negative is gonna be rejected, okay? Anyways, actually let's just do it, you never know. But when you do this, you're gonna get a negative answer. So akid it's gonna be rejected. It's not gonna be in this interval, okay? Try it, you'll see what you get. So I'm just gonna put this rejected. But you need to find the answer, don't just say it like that, okay? Find the answer. Whatever you get, you need to find the answer, and then say beside it rejected. Okay, don't just write it like this. Find the answer. Then shift sign radical 1 over 6. And 0.42. When you get negative 0.42. That's why you say rejected, because negative 0.42 is not in this interval. Here we get 0.42, which is in this interval here, because pi over 2 is about like 1.6, 1.5, something like that, and 0.42 falls in between the 0 and 1.5. okay, so that's why the value for x is going to be 0.42. okay, is that correct? 0.41. very easy. Type. Let's go now to page 27. Alright, now this question here came copy paste in the written, and it wasn't a top, so it may come the same for us as well. Okay, my job is to solve. So I'm gonna solve 40 as well for you, okay? Because it came in written before. So let's do this. Actually, I'm not gonna take it to open board. I'll use the space here. Over here, show that this equation has a root between 0.4 and 0.6. How do we show that it has a root between 0.4 and 0.6? Don't we use that one theorem called the intermediate value theorem, IVT? Doesn't IVT say that if it changes from positive to negative, then there's a root, or negative to positive, then there's a root? Yes. So let's find the function at 0.4. So at 0.4, it's 0.4 minus e to the power of negative 0.4, and you get a negative answer, negative 0.27, and then at 0.6, you get a positive answer. So let's just write it down, 0.05. So as you can see, since it changed from positive to negative, other way around, from negative to positive, therefore there exists a root. This symbol stands for there exists, in that interval. Anyways, then they're saying use the iterative formula to find the root to one decimal place. To use the iterative formula, you use this exact method. Okay, actually you start at 0. Now, over here, to use the iterative formula, when I said you start at 0, you basically need to pick a starting point in between the points that you're checking. Since we're checking between 0.4 and 0.6, you can choose anything. If you want to start at 0.4, that's fine. But it's best always, if you have two sets, to start somewhere in the middle. So 0.5. Alright, so simply all you need to do is radical. Hold up. Give me a second. Yeah, they're saying, this, this starting point that we use is an x value, right? It's an x value between 0.4 and 0.6. This is what we call xn. This is what you're starting with. So what we do is basically you have to check each one. So what's the formula they're giving us? You just apply what formula they're giving you. Radical xn e to the power of negative xn. So radical 0.5 e to the power of negative 0.5. And how much is that going to be? Let's see. You get radical 0.5506, yeah? Then what you do is you take this answer here, and that's going to be your new xn, always. That's why we call it iterative, because you keep on iterating it. This answer here, you plug it in again. So radical 0.5506 e to the power of negative 0.5506. You need to do this at least twice. You keep on doing it, keep on repeating until the answer stops changing. Okay, so radical 0.5506 e to the power of negative 0.5506, and you get 0.5635. Now as you can see, the answer barely changed. It only changed by 0.01. So that's why we can take this one as our answer. خلاص. Okay, they said to one decimal place, round this to one decimal place, you're gonna get 0.6. So 0.6 is your answer. Okay, it's gonna make more sense than what you solve. Let's do T2. Alright, the sequence here, given by iterative formula, whatever, use initial value 2, converges to alpha, use the formula to calculate alpha to 4 decimal places, give the result of each iteration to 5 decimal places, state the equation satisfied by alpha, and hence find exact value of alpha. Okay, very easy. So it converges to alpha, so we're starting with 2. So yalla, start with 2, and each xn is 2. So 3 times 2 to the power 5 plus 13 times 2 over 4 times 2 to the power 4 plus 4. Let's check how much this is. You get this 1 point, they want 5 decimal places, so 1.79412. 1.79412. Then the answer of this is the new number that you substitute in the next one. So 3 times 1.79412 power 5 plus 13 times 1.7942 over 4 times 1.7942, like 1.79412 power 4 plus 4. So let's do that. It's 3 answer to the power 5 plus 13 answer. No, you can't take answer, you have to take it to 5 decimal places. So 3 times 1.79412 to the power of 5 plus 13 times 1.79412 over 4 times 1.79412 to the power of 4 plus 4, and you get 1.74 to 5 decimal places, 1.74038. As you can see, from this one to this one, there was change. It changed by 0.05. That's still a lot, so I need to continue. So you take this one now and do the same exact thing. 3 times 1.74038 power 5 plus 13 times 1.74038 over 4 times 1.74038 power 4 plus 4. This is the brackets, huh? And you're gonna get, and now I'm talking, okay, and I'll do it tough, I'll do it here, wait. You get this 1.73292. Now what's the difference between this one and this one? Barely anything. Barely. See, it only changes by this one and only by 1. So that means this final answer, you can take it. They want you to round it to 4 decimal places. So 1.7329. Let's نشوف if this is the answer. They kept on going. Okay. Oh, they kept on going. Okay. They wanted. Okay, since they wanted to 4 decimal places, and you have to keep on checking to the 4 decimal places stop changing. So you see how it's the 4th decimal place is 3 on 3. This has to like stop changing barely. Like you see 214, 206, it's almost the exact same thing. On 292 to 214. So they have to keep on going. So now I'm not going to keep on substituting because, to be honest, okay. So like over here we got 1.73292. You got to keep on going until it barely changes. Okay. If you're not sure, keep on going. Okay. How did also they say each iteration? No. If you're not sure, keep on going until it's barely changing. So you see here they got this. Okay. So you just keep on doing it until it barely changes. And again, I think you got the idea. Okay, so to 4 decimal places is going to be 1.7321. Okay, now over here, state the equation satisfied by alpha. This is exactly how you do it. Okay, you need to follow these steps. Basically, you change all these x's, you change it to alphas. So it changes into alpha equals 3 alpha 5 plus 13 alpha over 4 alpha 4 plus 4. Okay, now why do we do this? Because we say that limit as n approaches infinity, okay, of this equals this. Okay, that's how you write it in the exam. Limit as n approaches infinity of whatever you have here equals the same thing, but instead of x's you have alphas. Anyways, you just cross multiply and find an expression for alpha. Cross multiply, you're gonna get 4 alpha to the power of 5 plus 4 alpha equals 3 alpha 5 plus 13 alpha. Move everything to one side. You're gonna get alpha 5 minus 9 alpha equals 0. Factor out an alpha. You're gonna get alpha 4 minus 9 equals 0. So you get two solutions: alpha equals 0 or alpha power 4 minus 9 equals 0. And this would lead to alpha 4 equals 9. So it would lead to alpha equal 4th root of 9, which is actually radical 3. Okay, plus minus. But over here we started with 2. So is it possible to get 0? No. And is it possible to get negative? Because bracket is plus minus, yeah? So is it possible to get a negative root? No. Only positive, because we started with a positive number. Okay, so it's going to be plus root 3, or it's going to be plus the 4th root of 9. So the answer is just simply plus root 3. When you do the 4th root of 9 on your calculator, you get root 3. That's why I wrote root 3, huh? Anyways, so that is the equation satisfied by alpha. Alpha is equal to radical 3. That's it. Alright, over here, 42, by sketching a pair of graphs, show that ln 2x plus 3 equals 3e to the negative x has exactly one real root. Alright, question 42. They're telling you sketch, and I'm not gonna lie to you, I really don't think this is gonna come. Yeah, this is the sketch if you want to see. But so I'll do part B and C and show by calculation that there's a root between 0.5 and 1. How do you do this? You simply take this to the left and get one equation. Ln 2x plus 3 minus 3e to the power of negative x equals 0. Hey, you have one full formula. Now you can substitute 0.5 and you can substitute 1, and you see when you substitute 0.5, is it here? You get negative 0.43. When you substitute 1 and you get 0.51, you see how negative and positive? That means there's a root. So since it changes, you get since it changes sign from negative to positive, then there's a root. Use the iterative formula to calculate the two decimal places. Always start in a point in between these two, so 0.75. So simply you start ln 3 over ln 2 times 0.75 plus 3, and you keep on repeating it, so on and so forth. You see here, you start with this, you get this, then you repeat it using this value, then you repeat it using this value, then you repeat it using this value, and then you start to see that these three are almost the same until like here they're pretty much the exact same. It's like 0.001 off. So over here, so these two are almost the same, so you stop there, and the two decimal places is going to be 0.70. Thank you so much for watching, and good luck in your exam.